Welcome to an example on how to solve an initial value problem involving a second-order Cauchy-Euler differential equation. A second-order Cauchy-Euler differential equation fits this form here. The important thing to notice here is that for each term, the degree of the coefficient, which is a function of x, equals the order of the derivative. We can solve a Cauchy-Euler differential equation using what's called an auxiliary equation, which is often expressed in one of these two forms here. We'll be using this form of the auxiliary equation. The solutions to this equation help us determine the general solution of the differential equation, where if the auxiliary equation has two distinct real roots, this is the form of the general solution. If it has two real equal roots, this is the form of the general solution. And if it has two complex roots in the form of alpha plus or minus beta I, then the general solution is in this form. In each case, we assume x is greater than 0. So the first step is to set up the auxiliary equation. Notice how a is equal to 1, b is equal to -7, and c is equal to +15. So for the auxiliary equation, because m is equal to 1, we'd have m times the quantity m minus 1, plus, for b times m, we'd have -7 times m. Let's write this as -7m, plus c, which would be +15, equals 0. Let's go ahead and clear the parentheses and combine like terms. So we'd have m squared minus 1m minus 7m, that's minus 8m, plus 15 equals 0. Looks like this will factor. We'll have two binomial factors. The factors of m squared are m and m. The factors of 15 that add to -8 are -5 and -3. So we have two real distinct roots or solutions. We have m sub 1 equals 5, m sub 2 equals +3. So because we have two distinct real roots or solutions to the auxiliary equation, our general solution will be in this form. Referring back to our notes just for a moment, notice how this is case 1 of the three possible cases when solving the auxiliary equation, which means the general solution is y of x equals c sub 1 times x raised to the power of 5 plus c sub 2 times x raised to the power of 3. And now we'll find the particular solution given the initial conditions y of 1 equals 7 and y prime of 1 equals 31. Before we do this though, let's find y prime of x. Y prime of x is equal to the derivative of c sub 1 x to the 5th plus c sub 2 x to the 3rd with respect to x, which should be 5 c sub 1 x to the 4th plus 3 c sub 2 x squared. So now we'll use these two functions in the initial conditions to find the value of c sub 1 and c sub 2. Let's do this on the next slide. Using y of 1 equals 7, we'll substitute 1 for x and 7 for y of x. So that would give us c sub 1 times 1 to the 5th, that's just c sub 1, plus c sub 2 times 1 to the 3rd, that's c sub 2, equals 7. And now using y prime of 1 equals 31, we'll substitute 1 for x and 31 for y prime of x. So if x equals 1, we'd have the equation 5 times c sub 1 plus 3 times c sub 2 equals 31. Now we need to solve c sub 1 plus c sub 2 equals 7, and 5 times c sub 1 plus 3 times c sub 2 equals 31 as a system of equations. So if we call this equation 1 and this equation 2, if we use substitution, let's go ahead and solve equation 1 for c sub 1. Using equation 1, we'd have c sub 1 equals 7 minus c sub 2. Now let's go ahead and perform substitution for c sub 1 in equation 2. So we'd have 5 times the quantity 7 minus c sub 2 plus 3 times c sub 2 equals 31. So we have 35 minus 5 times c sub 2 plus 3 times c sub 2 equals 31. Combine like terms, we have -2 times c sub 2. Let's go ahead and subtract 35 on both sides. That would give us equals -4. Dividing both sides by -2, we have c sub 2 equals +2. And now we can use this equation here to find c sub 1. C sub 1 is equal to 7 minus c sub 2, which would be 7 minus 2, which equals 5. Now that we know that c sub 2 equals 2 and c sub 1 equals 5, we'll perform those substitutions here and here to find the particular solution. We would have y of x equals, again, c sub 1 is 5, so we have 5 times x to the 5th. C sub 2 is 2, so we have plus 2 times x to the 3rd. This is our particular solution. So going back to the first slide, we'll go and enter that in here. Again, y of x equals 5 x to the 5th plus 2 x to the 3rd. I hope you found this helpful.